Okay, y'all. How y'all doing today? This might have been a challenge for y'all, but the solutions were integers. I think the solutions were 14 and 10, so you guys could have just guessed and checked. But if you want a more sophisticated approach to this problem, you can see this is how you would do it. Okay, so we're told some information, right? And that is two people are walking through a garden. One of them points to a rectangular garden and says, if I had made that bed 2 feet broader and 3 feet longer, it would have been 64 square feet larger. So 64 feet more than the area. Okay? But if it had been 3 feet broader and 2 feet longer, it would have been 68 square feet larger. So we're adding that to the area. And so this is the original area. Here's the adjustment of the dimensions for the first statement, 64 square feet larger than the original area. Here's the adjustments for the second statement, 68 feet larger than the original area. Okay, so you multiply to get the area. All right, now you might remember when we multiplied binomials, so we can go ahead and represent that like this, and the same thing with this one. Alright, so this would be x times y, that would be 3y, this would be 2x, that would be 6. This would be x times y, that would be 2y, this would be 3x, that would be 6. Sometimes people call this FOIL. The first, x times y, the outer, x times 2, the inner, 3 times y, and the last, 3 times 2. The first, x times y, the outer, x times 3, the inner, 2 times y, and the last, 2 times 3. So first, outer, inner, last. That's just another trick. You could also use this box model. So what does that mean? That means we have three equations. This is the first one. When we simplify this, we'll get xy plus 3y plus 2x plus 6. And when we simplify this, we'll get xy plus 2y plus 3x plus 6. And that's what equals these two things. Okay, now we have a system of three equations, and I'm going to erase all this. This one equals, and this one equals that. Okay, let's go ahead and simplify these two. Okay, so this is going to be 58. And this is going to be 62. All right, I'm going to call this the first equation, the second equation, and the third equation. We're going to use elimination. I'm going to take these two, subtract. We'll be able to get rid of the xy's. We'll be able to get rid of the a's. Then I'm going to take these two and subtract. We'll be able to get rid of the xy, and we'll be able to get rid of the a's. Okay, so first thing we're going to go equation 2 minus equation 1. So, in other words, bottom minus top. Okay, and we're going to do the same thing. Now we're going to do equation 3 minus equation 1, and again bottom minus top. Okay, now you guys can solve this system, and then what I would do is I'd multiply this one by -3, or rather 3, and this one by -2. And that way you'll be able to eliminate the x's. Okay, so then you get 9y plus 6x equals 3 times 50, 3 times 8, 150 plus 24, 174. Okay, multiplying this by -2. Two times 60, 2 times 2, 120 plus 4. Now you go ahead. This is 50. Okay, so y is 10. And then it doesn't matter which equation you use to get the x. So I'm going to use this one. Okay, so then 3 times 10 plus 2x equals 58. Subtract 30 and divide by 2. So x is 14. Okay, so the original area would have been 140. Okay, and then notice if you increase one by 3 and the other by 2, then you would have had 13 and 16, right? 13 and 16, which is 208. Notice that's plus 68. Whereas if you increased y by 2 and x by 3, you would have had 12 times 17, which is 204. And notice that's an increase from the original area of 64. Okay, y'all? I gave y'all an easier problem today involving quilt patterns with rectangles. And so you just match the dimensions. Hopefully it's not much of a challenge.